All right, so now we can talk about applications of trig functions here. So when we talk about applications of trig functions, really what we're talking about is we're going to be given something that's going to have something that deals with a triangle. Doesn't matter what it is, but we're going to have some type of word problem or some type of scenario where we have a triangle that needs to be formed. And then we want to find every single thing about that triangle, every side, every angle, based off of everything that we know so far. So we need to find all of our angles, which are always capital letters, A, B, and C. All of our lowercase variables are our sides, and they correspond to opposite of our angles. So angle A corresponds to side A, which is across from it. Same thing for angle C, it has side C. And then angle B goes to side B. So they're always opposite and everything. So given this triangle here, we want to find out everything about it. So we're going to use all the knowledge that we know. So first thing we can easily find is we can figure out alpha. So we know that the sum of all three angles must be equal to 180 is equal to 45 plus, since we see this box, we know that that's a 90 degree plus alpha. So 180 equals 135 plus alpha. So alpha is equal to 45 degrees. So now that we know what alpha is equal to, we can use either one of these to figure out what side B is and what side C is. So I'm going to use the one that they gave us. If at any point, to me, the best thing to do is if they give you some values, try to use them as much as you can, because if you make any mistakes on a calculation somewhere and you've used something that you found, if you made a mistake there, it's just going to compound. So I'm going to use this one to figure out that the sine, oops, sorry, not sine, can't use sine here, tangent of 45 is equal to opposite over adjacent. So in other words, 9 tangent 45 is equal to B. Tangent of 45 is 1, so therefore B is equal to 9. We know two sides of a right triangle, so we can use the Pythagorean theorem of 9 squared plus 9 squared equals C squared. So 162 is equal to C squared. So therefore C is equal to 9 root 2. Because when we took our square root here, square root of 62 is 81 times 2. Square root of 81 is 9, so we can bring it out. So we've now found every side, every angle, so therefore we have solved this triangle. Okay, so in this case right here, it says solve the triangle, round to the nearest hundredth as needed. So in other words, they don't want us to leave it as a square root like we did in the previous problem. They want us to actually find the decimal approximations. So angle A is 57.1. And side C is 52. So in our case, we have 180 is equal to 90 plus 57.1 plus angle B. So we have 180 equals 147.1 plus B. B is equal to 32.9. So this and this were my givens. So I'm going to use those to find little a right here. So sine of 57.1 is equal to a over 52. So 52 sine 57.1 is equal to little a. So little a is equal to 52 sine 57.1. So this is going to be 43.66. Keeping with that, I knew what the 57.1 cosine of 57.1 is equal to b over 52. So 52 cosine 57.1 is equal to b. So therefore b is equal to 28.25 if we round to 2 decimal places. So this is what we're doing every time whenever we see the solve the triangle. So on this one, I actually gave us a little bit more information here. So here we're given that side A is 10.6, side B is 23.6, and we need to find an angle. We can easily find C here if we wanted to go ahead and find that. That is 23.6 all squared plus 10.6 all squared is equal to C squared. So we're going to do a lot of calculator work here. To get that C is equal to 25.87. So I'm going to circle what our known values were. So to find angle A or angle B, it doesn't matter. So for angle A, we're going to take tangent of A is equal to 10.6 divided by 23.6. To solve for A, we're going to do inverse tangent to get A equals inverse tan of 10.6 over 23.6, which gives us that angle A is 24.19. Once we know what angle A is, we can take 90 minus 24.19 to get that angle B is 65.81. And the reason that we could go ahead and just subtract from 90, we know that 90 is right here. So we know that angle A and angle B must add up to 90. So that's why once we know one, we just subtract from 90. So the next thing we can talk about is bearings. Bearings come into play a lot in trig here, just because it's all about some type of degree. So when we talk about the bearing from point O, which is your origin, to some point P, where P is the acute angle, or actually all of this is an acute angle, it's measured in degrees between the ray OP and a north-south line. So the bearing from O to P in this first case. So in other words, we're going here. Let me change up colors a little bit, make it easier to see. So is north. So that means we're going to be going north, then 40 degrees east. So this angle here is my 40-degree angle. A lot of times we're going to be dealing with this angle down here, which means it's going to be the opposite of it, or the complement of it. We can also do this with a south line. So this is south, 70 degrees east, gives us this angle here. So we just have to kind of think about where we're at and what we're doing with each one of these here. So this one said, find the bearing from O to A. So they give us 61 degrees is between the east line and my ray OA. So what we need to actually find, we need this angle here. So we're going to take 90 minus 61 to get 29 degrees. So this one is going to be north, 29 degrees east would be the bearing here. We're not solving for anything. We're just finding the bearing. In a problem in just a second, we'll actually find stuff and we'll actually figure out what we can do with it. So a boat leaves the entrance to a harbor and travels 175 miles on a bearing north, 58 degrees east. So here's my north, here's my east. So we traveled north, 58 degrees east. So to find my other angle, this one is just 90. This angle just becomes 90 minus 58, which is 32. So it says how many miles north and how many miles east from the harbor has the boat traveled? So in other words, we're looking for this X and this Y. So for those of you that have to take physics, eventually this will be a case where you'll be breaking this down into the X and Y components. A lot of times you deal with force inside of physics there. So to find my X, we're going to use this 32. We're going to say cosine 32 is equal to X over 175. So 175 cosine 32 is equal to X, which gives us 100, and it doesn't tell me what to round to, so I'm going to round it to the nearest whole number. So X is equal to about 148 miles. To find Y, I'm going to use sine of 32 is equal to Y over 175. So 175 sine 32 is equal to Y. So the nearest is 93 is equal to Y. So how many miles north and how many miles east? So we're going to go north 93. We're going to go east 148. So that's where we're actually at in terms of where the boat is at. So these next ones, we got to kind of think a little bit and kind of see where we're at. So find X to the nearest whole number. So we're looking for X is this entire right side, this entire long side. So what we want to do here is I'm going to let this be Y and I'm going to let this be Z. So my Z, so in other words, they kind of stop right here. So what we're going to do is I'm going to use tangent of 8 is equal to Y over 100. So 100 equals tangent of 8. I'm sorry. Let me rewrite that. So 100 tangent 8 is equal to Y. So that means to the nearest whole number. So this is going to be I'm going to rewrite this as 14.05 is equal to Y. And then we'll do the nearest whole number in the end here. So to find Z, I need to use tangent of 20 is equal to z over 100. So 100 tangent 20 is equal to z. So 36.397 is equal to z. Well, x is z plus y. So 36.397 plus 14.05 gives me 50.447, which means that x is 50. So sometimes we have to break this up and use multiple triangles, but still use either the same trig functions or different trig functions. It doesn't matter. It all just depends on what we're given. So we're told we want to find x to the nearest whole number. So how can we do this? So one way to do this is I can find this entire distance. I'll call it y. So we can find that tangent of 34 is equal to 300 over y. So therefore y equals 300 divided by tan 34. Which is 444.768. But that's this entire distance. I need to find this little distance. I like working with right triangles, so that's why I did it the way I did. So now I need to find this. So how about tangent of 64 is equal to 300 over, I'll call this z. So z equals 300 divided by tangent of 64. That's 146.3197. So then x is equal to y minus z. So x equals, and so this was my y. This was my z. So we have 444.768 minus 146.3197. So that tells me that x equals 298 if we round to the nearest whole number here. So a lot of applications, we've seen this before with our angle of elevation and angle of depression. So now we're just going to actually use this in terms of it, because our angle of elevation just means that we're looking up. Angle of depression means that we're looking down from a straight line if we look straight out. So the Statue of Liberty is approximately 300 feet tall, 305 feet tall. If the angle of elevation of a ship to the top of the statue is 24 degrees, how far to the nearest foot is the ship's from the statue's base? So in other words, what we're looking for is we're looking for x here. So we always want to make sure we know exactly what we're looking for. So tangent of 24 is equal to 305 over x. So x equals 305 divided by tangent of 24. So when we do that, x is approximately 685 feet. So we always got to pay attention to what we're looking for and what we're given. So a helicopter hovers 1,000 feet above a small island. The figure shows that the angle of depression from the helicopter to the point P on the coast is 36 degrees. How far off the coast to the nearest foot is the island? Okay, so since we know this line is 36, we automatically know this is 54. 90 minus 54 gives me that this angle is 36. We could have used the 54 since we know that 100%. So we could do one or the other. We could either do tangent of 54 is equal to d over 1,000, or we could have used tangent of 36 is equal to 1,000 over d. It doesn't matter which one we use. If we use 1,000 tan 54 equals d versus d equals 1,000 divided by tangent 36, we're going to get the same answer no matter which way we do it. So if we work this one, we get 1,376. 0.38 if we really want to be more accurate, but it says to the nearest foot. If we did 1,000 divided by tangent of 36, we get 1,376.38192. So we still get the same distance no matter what of 1,376 feet. That's a long way to swim. So in applications, we're just solving for either what they're asking for or we're solving for the entire triangle. We're still using the same exact principles of our sine, cosine, and tangent. Nothing on that changes anywhere.